Assalamu alaikum everyone. Welcome to another video of Chemistry with Sarat Sambe. In this video, we are going to look at properties of giant covalent structures which were diamond, graphite and silicon dioxide in our case. We studied the structure and how the atoms are arranged in silicon dioxide, graphite and diamond. But let's talk about their properties. Again, all of these, so if I talk about the first property, that is melting and boiling points, all giant covalent structures have a high melting and boiling point. Have a high melting and boiling points. Why do they have high melting and boiling points? Because strong covalent bonds have to be broken. Strong covalent bonds have to be broken. In the case of diamond, it's strong carbon-carbon covalent bonds. In case of graphite, it's again strong carbon-carbon covalent bonds. In case of silicon dioxide, it's strong silicon-oxygen covalent bonds. So because strong covalent bonds have to be broken, which require high amounts of energy. To overcome them. Now, when I talk about the structure of diamond is a huge network of carbon-carbon covalent bonds. Hence, one of the property of diamond is that diamond is very hard. So let's specifically talk about diamond here. Diamond is very hard. And if I tell you a fun fact, diamond is the hardest substance present on the Earth's surface. So diamond is very hard due to the strong network of the carbon-carbon covalent bonds. And since diamond is the hardest substance on Earth, diamond can be used in cutting tools. Hence, diamond can be used in cutting tools. Tools which used to cut materials and substances, diamond is used in that because it's the hardest substance present. Let's talk about the structure and property of graphite. With reference to graphite can be used. Graphite can be used as a lubricant. Why can graphite be used as a lubricant? Is because if you look at the structure of graphite, it has weak intermolecular forces between the layers. What would these weak intermolecular forces do? The layers can slide over each other. So these layers can slide over each other because of the presence of weak intermolecular forces, and hence graphite is used as a lubricant. Because of the weak intermolecular forces, between the layers, allowing them to slide over each other. And a very interesting point, and graphite can be used as electrodes in electrolysis. When we will do electrolysis, we will see electrodes. Electrodes are substances that allow the electrons to pass through them. So why can graphite be used as electrodes is a very interesting point, that since each carbon atom in graphite is covalently bonded to 3 other carbon atoms, one electron of carbon is free. It is not bonded because carbon shares 4 of its electrons. In this case, in the case of graphite, carbon is sharing only 3 electrons, one with each carbon. So one electron is free to move. It's not bonding with anyone. So hence, graphite can be used as electrodes because 1 electron per carbon atom, 1 electron per carbon atom in graphite is delocalized. Delocalized means free to move. It's not fixed in a particular position. Is delocalized and can carry the charge throughout the structure. And can carry the charge throughout the structure. Now here, one thing about silicon dioxide is the same as diamond, is that since it's a huge network of silicon and oxygen atoms, silicon dioxide is also hard, and silicon dioxide also has a high melting and boiling points, because in silicon dioxide we have to break strong silicon oxygen covalent bonds which require high amount of energy. So these are some of the properties that can show up in the exam, and you need to thoroughly know them, and you also need to justify why are you stating that this particular compound has this property. So the explanations are written over here. This is it about giant covalent structures. In the next video, we are going to start and look at metallic bonding. So till then, thank you very much, everyone.